ohms, this is 3 ohms. Suppose this is 10 volts. Now 10 volts is the potential difference between the two ends. That means from the negative to the positive, the potential difference is 10 volts. Okay. So suppose this side is 0, this side will be 10. Suppose this side is -5, this side will be +5, because the difference between them is 10. Okay. Now, just for the sake of explanation, I am assuming that this is not true and this is true. This is 0 and this is 10. Okay. Now, if this is 0, this is 10, there will be some current in the circuit, which is very simple for you to find out. So the current in the circuit will be 10 by 5, which is equal to 2 ampere. 2 plus 3 is 5. So 10 by 5, 2 ampere. That means 2 ampere current will pass through this. Okay. Now, if 2 ampere current passes through this, here there will be a potential drop. So that potential drop will be 2 into 2, I into R. So that will be 4 volts. This point here is connected to this, so it is 10 volt. Now here there is a potential drop. Potential drop means of 4 volt. So this will become 6 volt. This will become 0. So here there is a potential drop of 4 volt. Here there is a potential drop of 6 volt. Okay. So in this particular circuit, I have, if this is 0, this is 10, this is 2, this is 3, this point will be 10 volt, this point will be 6 volt, and this point will be 0 volt. Okay. So I am assuming that all of you are able to understand this. Yeah, I will do. Don't worry, Ashwin, I will do. But right now, simple questions first. Okay. Yeah, henceforth it will be happening every day. See, there are many issues I have to think about. First thing is, I don't know how many hours your school is engaging you. We are engaging you for 4 hours. Assuming your school is engaging you for 1 hour. Assuming you are getting 1 hour entertainment online. So totally you are with the system for 6 hours. I think this is more than enough. Okay, so if you do more than this, it is not good for you. So that is the whole concept. I don't mind doing whole day class, but you have to be benefited of it. Okay, anyway, forget it. This is not an important issue. So now this, I hope all of you are able to understand. Now the moment you understand this, I am now having another resistor here and another resistor here. This let me say is 1 ohm. This let me say is 3 by 2 ohms. Okay. This let me say is 1 ohm. This let me say is 3 by 2 ohm. Now, when the current comes this way, the current will go past this, go this way, and then come back this way, come back this way. Yeah. So this is how the current will go. So now let me find out the total resistance here, 1 plus 3 by 2. So that will become 5 by 2. So what is the current in that circuit? 10 divided by 5 by 2. So that will become 4 ampere. So the current now is 4 ampere here. So now here the potential, because this is connected to this, so this will also be 10 volt. Now if this is 10 volt, the potential drop here will be 4 into 1. So that will become 4 volt. So the potential for this point is again going to be 6 volt. So this is 6 volt, and this potential here will again be equal to 0. Now, do you understand this? Do you understand this particular concept? So here it is 6 volt, here also it is 6 volt. Okay. Yeah, the total current is 6 ampere, but we are not interested in that. Okay. What we are interested in is understand that this point and this point are at the same potential. Okay. This point and this point are at the same potential. So now when you have 2 points at the same potential, you may connect a wire between them. You may remove the wire between them. Whatever you do, it is not going to affect your answer at all. You may connect a wire between them. You may remove the wire between them. Whatever you do, nothing is going to happen. It is not going to influence anything in any way. Okay, so what we had there is this. We had there as 1 ohm, 2 ohm, 3 ohm, 3 by 2 ohm. Now, in this case, because these ratios are the same, I can say directly that these 2 points are at the same potential. Okay. Now, whenever 2 points are at the same potential, connecting any wire or removing any wire, I mean any resistor, not wire, any resistor will have no influence. Do you understand this? Yeah. Now this is the fundamental logic behind the Wheatstone bridge, behind this concept of symmetry. This is the fundamental logic behind that. Okay, so I will now use this logic and explain you a few questions. Yeah. So now suppose you have a question of this kind. All these are resistors, okay? All yellow is resistors, all equal resistors. So now suppose you have a situation of this kind. All equal resistors, all the yellows are resistors. Yeah. Now how are you going to solve this? Now I want to first identify a line of symmetry. Okay, here is a line of symmetry. Wherever this line is crossing, the left side and the right side are exact mirror images. The left side and right side are exact mirror images. Because they are mirror images, these points will be at the same potential. Now, in this case, I am not just saying that the ratios are the same. I'm saying left side and right side are the same. Now, because left side and right side are the same, and this is okay, they'll all be at the same potential, exact midway. So if this is 10 volt, this will be 5 volt, this will be 5 volt, this will be 5 volt. I'm assuming 0, 10. If it was minus 5 and 5, it will be 0, 0, 0. Okay, so whenever you have such points, you can connect wires and connect them. So that is what I'm going to do. Sir, do platinum resistor thermometer work in this process? No, platinum resistor thermometers work in a different process. I will explain that to you later. Okay, so I can connect them now. So now when I can connect them, I can break this resistor. So what I'll do is I have one, I'm redrawing the circuit. I'm redrawing the circuit. That one has been broken into 2 halves. Okay, so now because they're all the same, this is broken into 2 halves. So R by 2, R by 2, R, 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 R by 2, R by 2, R, 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 everything, R, R. Now I can find out. Now series parallel. These two are in parallel. Series, parallel, series, parallel, series. So now you find out what the answer is. Quickly, please work it out and see if you're able to get it. Yeah, quickly work it out and see. Excuse me. Okay, so I hope this is done. This is one of the doubts that I was asked. I hope I have worked it out. Yeah, so yes, so I hope this I have helped you out. Okay, now if you have any other doubts, you may write down. I'll do some RC circuit questions also. So this is how you work with it. Yeah. Then I will just do one or two more circuits. Especially I want to work out the cube one again, so that we will understand a little bit more about it. See, basically the only way to learn these things is to apply. By listening to it again and again and again, you won't get it, because you'll still be making some mistake and you don't know what. So the only way to do it is to work it out, get it corrected, work it out, get it corrected. There's nothing else that can be done. So here I have this. Now I was connecting the wire on this side. Okay, now suppose I name this A, B, C, D, E, F, G, and H. Now, can you point out points to me which will be at the same potential? Can you point out, or can you write down points which you think will be the same potential? Okay, I will say some points. H, D, B. Just tell me whether it is true or not. I am telling you that H, D, B are at the same potential. H, D, B are at the same potential. True or false? So you are understanding that they are at the same potential. Why are they at the same potential? Somebody may want to ask. Now again, you see, if you look at this point, its orientation with respect to this point and this point, then this point and this point with respect to the two ends is the same. That means from here, one resistor you come to positive terminal, two resistors you go to negative terminal. From here, one resistor positive, two equal resistors negative. One resistor positive, two equal resistors negative. For some reason, if I say everything is R and this is 2R, now it is not the same. Because they are all R, only then it is the same. Okay. So now I can redraw this diagram by connecting wires like this. That is, I will put all these 3 points together at the same place. Similarly, I can put these 3 points together at the same place. So if I put H here, if I put a D here, if I put a B here, now there is one resistor to H, there is one resistor to D, and one resistor to B. All these are connected to the same positive terminal. Okay. Similarly, if I have F here, there is one resistor, there is one resistor, one resistor. Now this is G, this is E, and this is G, E, and C. So G, E, and C, they are connected, and they are connected to the negative terminal, and they are all connected together. They are all connected together. They are all the same point. I hope you are able to understand this. Yeah. Now, once you bring them together on this side, from H to G, there is one. Yeah. H to E, there is one. So H to G, there is one. H to E, there is one. Then what else is there? D to C, there is one. So D to C, there is one. Then what else is there? D to G, there is one. Okay. D to G, there is one. Then again from B to C and B to E. So I have one more here and I have one more here. So the equivalent resistance of this is here. Huh? The equivalent resistance of this is here. Now, what is the effective resistance of this 3 parallel R by 3? What is the effective resistance here? 3 series R by 6. What is the effective resistance here? 3 parallel R by 3. Now, they are all in series. So, it becomes R by 3 plus R by 6 plus R by 3. How much is it? 6 LCM. So, 5 R by 6. Do you understand this? Excuse me. So I have used the same concept that we have learned before. If you have points which are at the same potential, you may simply connect them, or if there are wires, if you want, you may remove them. Both works. Okay, can you quickly complete this? We didn't do it this way when we did it in the class. We did it in a different way. There are many ways of doing questions. It all depends on what logic, how we are using. So I connected these 3 points. Similarly, I connected these 3 points. Yeah, so if you understand that, we will move on. No, this one is not, but this way is much easier. Yeah. True. See, the whole idea is to use the theory that we learn. That is the important thing. Yes, we can also find by drawing currents. I just wanted to show you that there are this other methods also. There are other methods also. Okay, if you understand that these 3 points are at the same potential, these 3 points are at the same potential, I can redraw the circuit. Once you redraw the circuit, things become much simpler. Now, some questions are easy this way. In some cases, it will be more difficult this way. It will be difficult this way, easier though current method. So, we have to just understand how to approach a particular question. And the only way you get this is practice. I mean, one thing that I tell all my students, friends, any chapter that you have to do 200 at least standard questions. Okay, so one notebook we used to finish for each chapter. So if we do current electricity, means current electricity will be one notebook where we write some 15-20 pages of theory. After that, only solved examples. Your theory can develop only when you work out solved examples. Okay, so good. So if this is understood, I will just do one more question of this kind, then I will change. Okay, so I'll do that other cube question where we were. Here. Okay, again my job is first is to draw the circuit and understand what are the points. So here I will do A, B, C, D, then I have E, F, and I have G and H. Okay, so now let me see. I want to identify points which are at the same potential. Very clearly you will see this point B here, you will see this point D here. Now it's going like this, right in the middle it is. So suppose this is plus 5 and this is minus 5. Do you understand that B will be 0? Do you understand that D will be 0? Yeah. Similarly, if you look at this, now this will be the exact midpoint. So this will also be 0 and this will also be 0. Yeah. So now here, not only are these 2 points and these 2 points at the same potential, because they are at the same potential, I can remove this, I can remove this. Not only can I remove this, if I want, I can add this, I can add this if I want. Yeah. So do we understand this? So now if I don't have this wire, if I don't have this wire, you see this is a nice series circuit. This is a nice series circuit. Yeah, and these two are in parallel. Now you see this whole thing will be in series. Same thing, parallel, parallel. I'm series, parallel. Now these two will be in parallel. Quickly find out the effective resistance. For every question, your approach should be, what is the theory? Answer is not important. Answers will come. First you learn the theory, answers will come. And you have to learn theory by applying or problem solving. There is no other way to learn theory. Reading theory 25 times, 100 times, writing it, not going to make any difference. Okay, H is in the same orientation as to A as D. H is the same orientation to A as D. Yes, I have no problem. You are right. H and D are at the same potential. No problem. But it won't help me. There are other things which have already helped me. So I don't want to use everything. There are many tools. I don't want to use. So I mean, there are many hints or many substeps. So I don't want to use all the steps every time. So A, B, C, D, E, F, G, H. Okay, in this case, yes, E and B are at the same potential, no doubts about it. You can connect them. Similarly, F and C are also at the same potential, but we don't need it, because removing this and removing that and removing this, that itself is going to solve your problem. So the moment you solve that, those take out those two, you have, this is the situation. This is your drawing. Okay, so this is your drawing. Now this drawing is very simple. R here, R here, R here, R here. So this is 3R. So this is 3R. This is 2R, 2R, R. So 3R and R will become 3R by 4. I get the answer immediately. So I don't really have to bother about B and D. Okay. Yeah, last question also, potential could have become 0. Potential could have become 0. It depends on what you are taking. In the last question, yeah, in the last question, if I had made this +5 and I had made this -5, then also I can only say that these are at the same potential. I can't say 0 potential. I can say 0 potential if a left side, right side are mirror images of each other. Okay, now you see in this particular case, what is happening is, because I am applying the potential here, now this path and this path are the same. So here you are, suppose at +5, here you are at -5. What do you think will be here? Here you are at +5, here there is something I don't know, here -5. You see, it is the same thing. Whatever you have here x, here also x. So this has to be 0. But in the previous case, it was not like that. Suppose this is +5 and this one is -5, then why should this be 0? Because this is closer to this than this, right? So this won't be 0. This won't be 0. So you have to understand that. This particular case we did, this was 6 volt. Why was this 6 volt? It could have been 5 volt. Had these two been equal to each other, 2 here, 1 here, 1 here. Now it will be 5, 5. Or if I put plus 5 and minus 5, it will be 0, 0. Okay. So that is the difference that we are talking of. Yes, are we able to understand? Positive terminal connected to A and negative terminal connected to C. Which one? Yeah, I did. I'm doing that question only, right? Positive connected to A, negative connected to C. Yeah. So quickly work it out. Yeah. Then, okay. Any other responses quickly give? Then we'll move on. Okay. So if this is understood, then let's move on. So the next question that you have, is basically when you connect here, if you want to identify points which are at the same potential, you know, maybe this point, this point, this point, and this point. I don't know how it is going to help us, but I'm just telling you. So those points are at the same potential. Then this point, definitely E and B. E and B are at the same potential. How do you know? See, it is one resistor from positive. This is also one resistor from positive. Then it is two resistors from negative. Here also it is two resistors from negative. Yeah. So E and B are at the same potential. Then, but they are not at the zero potential. If this is plus 5 and this is minus 5, they won't be zero potential. They'll be the same potential. Similarly, I can have points. Similarly, E and B I have seen, C and F. These two also are at the same potential. So now what do I do? So because they are at the same potential, I can connect a wire like this and I can connect a wire like this. Now I am just, now I'll redraw the circuit. So basically EB and FC will come together. So EB and FC will come together. So if EB and FC come together, so up to a point H, from E I have a wire and from B I have a wire. Then I have this. Then from G, this is E comma B. Then I have another point here, F comma C. So I have one wire here and I have another wire here. Okay. So I have drawn that part of the circuit. Now I have to draw this part of the circuit. No problem. So from EB, yeah. So E to F there is a wire and B to C there is a wire. So here there is one wire here and there is another wire here. Then from E to A there is a wire. E to A there is a wire. Then E to A there is a wire. There is a wire from there to B. So this is the point A. Similarly, from here there is a wire and from here there is a wire. Now AD are also connected by a wire and the potential drop is across AD. So this is my equivalent circuit. So EB, A is there, A is there, D is there. So A, B, C, D is over, E, F is over, this is H and this is G. So now my equivalent circuit is over. So once the equivalent circuit is over, now I can try to work it out. So these two are R by 2. This is R. This is R by 2. Then this two, if you add all of them, it will become 2R. This is R by 2. So 2R and R by 2 are in parallel. So you can work that out. 2R into R by 2 divided by 5R by 2. 2 gets cancelled, RR gets cancelled. So it is equal to 2R by 5. So this is 2R by 5. Yeah. Now this is R by 2. R by 2 plus 2R by 5 plus this one is again R by 2. They are in series. So I can have 10 here. So it will become 12R by 10. Now this R and 12R by 10 are in parallel. So into R divided by 12R by 10 plus R. So now when you work this out, you will get, oh no, I'm making an error. I'm making an error. I'm making an error. This is fine. 2R by 5 is fine. Oh no, no error, no error. Now this R by 2, this and this are in series. So once you connect them in series, now these two are in parallel. So 12R by 10, 12R by 10 plus this is R. R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. Divided by 12R by 10. 12R by 10 into R divided by 12R by 10 plus R. So if you multiply them, it will become 12R by 22. That is 6R by 11. I can't remember the answer, but I don't think this was the answer. So if you guys can just do it carefully and then check, it maybe it will help. So this is R by 2, R by 2, 2R, no doubt about it. This is R by 2, no doubt about it. So 2R into R by 2, so that is 2R by 5, okay, no doubt about it. So this is 2R by 5. So R by 2 plus 2R by 5 plus 2R by 5, sorry, plus R by 2. So LCM is 10. So this will be 5R plus 5R plus 2R. So it will become 12R by 10. That is 6R by 5. So these three are 6R by 5. 6R by 5 into R. Yeah, maybe just check if this is the answer. If not, I'll do it again. But important thing is to be able to understand what we are doing. Okay, I missed RAD. I have RAD here. Yeah, just work it out. Please work this out. EB, AD, and FC are in series. Okay. That's the error. So here is the error. So this is, we took it as 12R by 10. It should be 14R by 10. Then you will get the answer. Perfect. Sorry, I mistake. Here there is a 5, so it should be 5R plus 5R plus 4R, not 2R. Okay, that was error. Don't worry, concept is fine. So this concept is absolutely fine. So focus on the concept. Okay, now the only way to improve your logics, the only way to improve your capabilities is to do more and more problems. Don't feel bad of getting wrong answers, or always wrong answers is the first step. You can't get wrong answers forever. Nobody has ever happened like that. They have got wrong answers forever. Initially you will always get wrong answers, but slowly they can improve. Okay. So anyway, so here this is the part I was asked. I have explained that. let's do a few questions now on RC circuits. Okay. Now, before I do RC circuits, let me just explain the question that I was doing yesterday so that that will help us a little. Okay. So now, what was the question here? It was like this. This is R1, this is C, and this is R2. Okay. This is V. Yeah. Now, like always, understand what is happening is because of this potential, initially the charge on capacitor is equal to 0. Initially, Q on capacitor is equal to 0. So the moment this circuit is on, charge is going. So there is some current which is going this way. Yeah. Suppose the current I is going this way or I1 is going this way, this side will become I2, and this side some car current is going which deposits charge on this particular capacitor. So now let the charge on this particular capacitor be Q. So here I have a loop, so I can write Kirchhoff's law. So I'll get V minus I1 R1 minus Q by C is equal to 0. Or I will get V is equal to I1 R1 plus Q by C. Yeah. So this is one. Second, you know, this is a closed loop here. So you will get I2 R2 is equal to Q by C. But look, we have to solve, we have to write it as a differential equation and then we will have to solve it. Because mere substituting this there are two unknowns. There are three unknowns. I1 is one unknown, I2 is one unknown, and Q is one unknown. So we will have to see how we can solve a differential equation by working with this. Yeah. Now, by charge conservation concept, I can say that dq by dt is equal to I1 minus I2. Some current is going this way, majority goes this way, a small portion goes this way. By conservation of charge, rate of this flow minus rate of this flow is equal to this flow. So dq by dt is equal to I1 minus I2. So now here I have two equations. Based on these two equations, I can try to find it out. Yeah. So I have V is equal to I1 R1 plus Q by C. Then I can say 0 is equal to minus I2 R2 plus Q by C. Yeah. Now, if I just add them, I'll get V is equal to I1. Oh no, I have to multiply these. So I have to multiply this with R2. I have to multiply this with R1. Then I will get VR2 plus is equal to I1 R1 R2 plus R2 Q by C. Now on this other side, I'll get 0 is equal to minus I2 R1 R2 plus R1 into Q by C. Now I'm just going to add them. So I'll get VR2 is equal to R1 R2 into this is I'll get I minus I2, which is equal to dq by dt. Now I'm adding them, right? So R1 plus R2 Q by C. Okay. So here you got a differential equation. Our whole aim was to get the differential equation. Once we get the differential equation, we can solve it. Now it gets a little complicated, but I explained to you. I solved it and then I showed to you. This is how you work with Now I will try to teach you how to find out the solution for such an equation. If you have a normal capacitor, and if you have a resistor connected to a voltage, then I can say that V is equal to IR plus Q by C. I can say V is equal to dq by dt R plus Q by C. Yeah. So now I can say VC minus Q by C is equal to dq by dt R. So I can say dq RC divided by VC minus Q is equal to dt. This is how you solve a typical differential equation. The way you solve them is to put all variables of one type on one side, other type on another side, and then you try to solve them. So this is one technique. So when I to solve this, I'll now integrate both the sides with respect to Q and T. So I'll get RC by this one will become log VC minus Q. Because of this minus here, it will become minus. Now this is equal to, the limits are from 0 to some Q. This is equal to T. The limits are 0 to some T. So now when I work with this, I will substitute these. I'll get minus RC ln VC minus capital Q minus RC ln VC is equal to T. So now when I work this out, I'll bring this RC down here. So I'll get ln. So I put the minus this side. So this, okay. So I'll get ln VC minus Q minus ln VC is equal to minus T by RC. So you'll get ln VC minus Q by VC is equal to minus T by RC. Now I am taking the inverse of this. I am taking an exponential function. So I will get e power minus T by RC is equal to VC minus Q by VC. Now you rearrange it and you will get Q is equal to VC into 1 minus e power minus T by RC. What is VC equal to? VC is equal to max charge. A capacitor C is connected across potential V, so that is a max charge. First you make a note of this and then we will reach. This is the final step. I'll be back in a minute. Sir, why we are taking AD is parallel in the previous question? In the previous question, why we are taking AD is parallel? Why we are taking AD is parallel? AD is not parallel. These three are in series. These three are in series. Now these three are in series. Actually, I'm sorry, these three are not in series. Sorry, these three are in series. These two are in parallel. Then these are in series. Now, then this comes up. I'll just explain to you here. See, you have one resistor here across which you have the battery. Then you have this, then you have this, then you have this. So what can you say? These are in series. Then what can you say about this? They are in parallel. Always you should work from the furthest end. Always work from the furthest end. Never work from the nearer end. Always work from the furthest end. So keep simplifying only the furthest end. Nearest end you can't work. So the moment you understand this technique, you will not make mistake. Okay. Yeah. So Sharan, I hope you are able to understand. Okay, this RC circuit, has it been understood? Do we understand this? Yeah. Hmm. Now the kind of questions that you may get. So we will talk about that. So first, if you understand this, then uh, then see Q is equal to Q0 into 1 minus e power minus t by RC. Okay. Suppose T is equal to RC. Then what will we get? We will get Q is equal to Q0 into 1 minus e power minus 1. We will get Q0 into 1 minus 1 by e. That means you will get Q0 into e minus 1 by e. E is something like 2.7. So you will get Q is equal to Q0 into 1.7 by 2.7. When you work it out, it works out to be some 63% or something. So that gives you the definition of time constant. One time constant is that time during which the charge on the plates of the capacitor reaches 63% of max charge. This is one. Second thing is, understand that if this is time and this is Q, it increases and then it here. So there is a steady state. It reaches a steady state after some time. Yeah. Then understand that here dq by dt is highest. That means resistance is lowest. That means current is max. While here dq by dt is almost 0. That means I is equal to 0. That means R is infinity. Do you understand? So, do you understand that a capacitor offers variable resistance the moment it is connected to 0? The moment it is connected to the circuit, R tends to 0, and once steady state is reached, R tends to infinity. The once steady state is reached, then R tends to infinity. RC, R for resistor, C for capacitor. So you have RC circuits. Okay, do you understand this? Okay, now we can talk about a lot of things. We can talk about rate of change of energy, that is rate of storing of energy. So from here, we can find out the rate at which energy is stored. So that is equal to Q by C into dQ by dt. Q is equal to how much? CV into 1 minus e power minus t by RC divided by C into dq by dt. dq by dt will be CV into e power minus t by RC divided by RC. So this is going to be the rate of energy stored. So this C gets cancelled, this C gets cancelled. So it becomes V square by R, yeah, into e power minus t by RC into 1 minus e power minus t by RC. What is V squared by R? Maximum energy stored, maximum energy drawn from the battery. This was my circuit. If there was no capacitor, that current, that amount, the energy loss in the circuit would have been V squared by R, or the power in the circuit would have been V squared by R. So now it is V squared by R into this factor. This is the rate of transfer of energy. How much energy is going to the capacitor per unit time? So these are all the different questions that we may be getting as far as this is concerned. The other type, of course, we will see. They work with the charge on the capacitor, how much charge will flow through the battery, and those kinds of questions that we will see. But this is the crux of RC circuits. Okay. From where we got the value of dq by dt. Q is equal to Q naught into 1 minus e power minus t by RC. So we differentiated this. When we differentiate it, we'll get dq by dt. So this is constant. So minus Q0 e power anything, the differential is e power this, divide into the 1 by RC, minus 1 by RC. So the minus minus became plus. So that is how we got the value of dq by dt. We differentiated this quantity. By differentiating this quantity, we got dq by dt. Okay. So fine, I will stop here. See you again. If you guys have any questions, ask me. I'll be happy to answer. Next class, I will work out some questions only on circuits with capacitors, not with how much charge is there, but with multiple capacitors. I mean, the other kind of questions that you may get is something of this kind. See, suppose there is a battery here, there is a capacitor here, there's a capacitor here, there's a capacitor here, there's a capacitor here, here, and let's say here. Let's give values to it: 2 mu f, 2 mu f, 4 mu f, 2 mu f. Let's call this 4 mu f. Let's call this 10 volt. Okay. So now the question is, what is the charge on each of these capacitors? How will you work it out? Okay. So next class, I will discuss these kinds of questions. Now the way we work it out is that first find out what is the net charge. How will you find out the net charge? By finding out the net capacitance. So you know C is equal to Q by V. So Q is equal to V into C effective. So series, parallel, series. Find out the effective capacitance. Multiply it with 10 and you get the charge. Now understand that the charge on this plate will be that much positive, whatever you find out. Okay, so if you want to work it out, this will be 4 into 2 by 4 plus 2. So that means 8 by 6, that means 4 by 3. 4 by 3 plus 2, that will become 10 by 3. Okay, now I have 1 by 2 plus 1 by 4 plus 3 by 10. So the LCM is like 20, 10 plus 5 plus 6. So that will become, effective will become 20 by 21. Yeah. So if the effective capacitance is 20 by 21, Q will become equal to 200 by 21. So the charge on this capacitor will be 200 by 21. The charge on this will also be 200 by 21. Okay. Now this plate is plus, this plate will be minus. Now here this plate will be minus, this plate will be plus. Now understand that the charge on these two plates will be total equal to 200 by 21. Now both these capacitors are the same. Yeah, both these capacitors are the same. So the charge will go from here to here till potential becomes the same. Potential becomes the same. But now understand that here there is not just two, both of them are there. Okay, so find out the effective. Now divide the ratio. For potential to be the same, C is equal to Q by V. So V is equal to Q by C. So if suppose Q1 is there here, Q1 by C1 must be equal to Q2 by C effective. C effective being this. Now first find out the ratio, then divide 200 by 21 into that and then work. Anyway, next class I'll work more of these. You all think about it. If you have any questions, please post them. Please put them to Rajshekhar. Please put them to anybody. Please put, but please ask questions and don't feel miserable as far as the subject is concerned. Okay, fine. I will stop here. See you again tomorrow. Bye bye.